Yeah, good morning, everyone. My name is Bablu Banik. I will be graduating within, I think, 2 weeks from Cal State, Monterey Bay. Um, and I do work in the industry. I spent almost 5 years in the software testing, but my focus was on the fintech, financial industry. And recently, I have worked on in the e-commerce right now. So the software testing is a very big part of my career that I do almost every day. And that's what I kind of interested in learning more about software engineering more, and especially with the focus of software testing. So and the most of the time that we see in the software testing is the big problem that I come up with to create a software test plan. Um, and how to determine an exit criteria. So I would always wanted to know how we can give a better exit criteria uh, because there isn't no hard and fast rule. There is some guideline that can help to decide, but every project is different, and every industry is different. Every standard is different. So I look into the part of this research. I look into the different aspect, different ways to determine how we can, find a better way to minimize testing, but not at the cost of, making our application unstable or insecure. We want to keep that in mind, that we want to keep an application secure, workable condition. It does a job. It does not creates more bug. Those kind of things we have to keep in mind. But it's kind of a trade-off. If we test more, then you have a peace of mind that you are covering all the use cases. But due to the lack of resources, in terms of time, in terms of manpower, in terms of financial resources, it's not possible to test everything or to keep the testing for indefinite time. So different approaches have been developed, and as a part of this research, I really look into the combinatorial testing. So I choose the combinatorial testing because it is widely been used in the software industry, and it has been also used in the academic area. The benefit of combinatorial testing, it really helps to cut down the testing scope. So we don't have to test many or all these use cases um, to to find the bug. But for example, if I have a word processing application with 10 input fields, then I may have to test 124 use cases if I choose to go with exhaustive testing. That would give me a peace of mind that hey, every single one is tested, and I know everything is worked. But think about it, if the numbers goes upper, like now I have 10 input, so if numbers goes 100 or maybe 200 or 1000, then the number of test cases that we have to execute as a part of exhaustive testing is very big, and the effort would be in a numerous. It's kind of impossible to achieve all these test cases within really the given time frame. And at combinatorial testing, we look into that combinatorial testing, and we saw, at least I saw, that there's a different tool exists, and using those tools and an aspect of it for application with 10 input field, we can only test 13 distinct tests, and that would give us almost 90% of the application being tested, and it will help us to find at least 90% of the bug, at least the critical and major bugs, which I think the most appropriate for an application with word processing. But the things would a little bit different if we consider to test an application which has a safety critical in mind. So let's say if we are trying to test some airplane, then the standard of the testing and the scope of the testing would be more. So therefore, I really need to look into the other aspect and other resources available to know what other things that I have to look into the system to know what need to be tested for a safety critical software. The few things that I found common for a safety critical software that we have to really test and is we have to really find what are the different combinations or what are the different tasks we have to test, and each task would have one or more paths. So we really have to focus and spend time and give kind of consideration to finding out all those tasks, all those paths. And once we have those all these informations, then we have to basically going to the prioritization and selection which path we probably want to test to get the best representative for other paths that are kind of coming in the same category. So that brought me to read through a paper that was published last year. I think Professor Rong and other scholars were involved in that paper. That paper gives me a good overview how conventional testing being used in Internet of Things applications. So in that study, that special consideration was given on the test task was how to create a different testing path and a different expression how we can manipulate those, and there was also given a special consideration how they identify and select specific path and how they are executing those test paths. Going through those study, and the few things that I found that are really helpful to know as a part of definition is how to define the testing task, testing path, and some few guidelines that I feel that will be more helpful for me, and I just think those are takeaway for me from this RU program. So the way testing path was task was defined is testing task is usually described as what this testing task is. Like for example, if a person in a parking lot of this application is basically was for a parking lot testing. There was two parking lot with I think they are kind of identical, but there's kind of little differences. For example, first parking lot has Wi-Fi based network that connects to the remote server, and second one is kind of with cellular based network on that, but they have a lot of things in common. So, like for example, if someone wants to looking for a parking, that could be categorized as a task. But if you look into that example, then if you're looking for a path from that task, that could be a numeric task, a numeric path. So a path has been described as a step-by-step description how to test a task. So the definition of path and definition of test case is kind of similar to me, because test case is also defined as a step-by-step description how to test an application. So path can be a person, how the person is looking for a parking lot by phone, or maybe he was going to the parking lot and he was finding a spot and he parked there. So those things can be defined as a parking. Sorry, as a path. And when you go through that, there is few guidelines that I feel as most helpful. Like for example, that I saw that the requirement needs to be really specific. If requirement is not specific enough, then it gives a broader scope for testing. Like the earlier example that I cited, a person looking for a parking lot, that gives a broader scope, wouldn't know which parking lot he was looking for a parking. In that case, our testing scope extend on both parking lot A and parking lot B. Also, we are not sure how we're looking for parking, whether he was driving physically or he was looking for a parking spot from an app that installed in his mobile phone. That brings the second point. If you're looking for a parking lot in his mobile phone, which requires more testing because each mobile phone or mobile devices is different. Therefore, there is more customization involved, and more customization requires more testing, which really broaden the scope of the testing. And another thing that we need to really consider as a part of the guideline when you're testing, we really have to know which of the path that have devices that are not being tested, or they don't have a representative device that never been tested. Those paths really we have to prioritize because those have higher priority. And another part that we have to really test is the edge cases. Like in software industry, we call it a boundary test. Like for example, if I have a number 0 to 99, I definitely want to test 0 and 99 at the beginning, just want to make sure edge cases are good. Similar concept is here. The edge cases of a two-street parking lot needs to be tested, especially the exit and entry. And those are the very important. If someone cannot entry or someone cannot exit, that is the bigger problem. So we really have to need to test those. So now I took these ideas and I look for the way how we can implement those in some kind of specific example. So one of the examples that I found through my research and online that how the parking lot being tested with different aspects, with the charges, the machine charges or parking lot charge for a spot for a parking lot. So for example, if I park my car in a parking spot in a day or in the night, the rate is different. Especially I live in North Hollywood, so we have a metro station. So their parking lot, the charges for the day and the night are different, and the fee the charges during business hour versus weekend are different. And they also have a grace point. So the grace point, they are not even charging any money. So those combinations are really important, and we really need to take those combinations at the very first. But the scope is really big. How we want to test all these things. One of the suggestions that I learned from the study is that we really want to test the transitions. The what transition I mean, if someone park the whole night, let's say he parked all night, so he has only $2 parking for the whole night, but he also extend his parking maybe up to 11 a.m. in the morning. So how the system will determine how much system will charge him for from 5 a.m. to 11 a.m. That rate would be really high, not like night. So we need to test that transition area very thoroughly, because that should have a higher priority, because that transition would not only test us one night, it also has a test to the day as well. Definitely need to test the grace period, because that is the most thing people are going to use. People will try to park when there is no parking charge. So we have to really test that area. It is commonly used. The edge cases I already mentioned, and yeah, so those are the takeaway that I can use to test and broaden our scope, how we can proceed with the testing. Now we have learned a couple of things, and now it's time to take those input and takeaway from the study and research and put in real life. And I'm looking for using those concepts in solving the problem that I have initially to determine how we can exit the software testing so that we can provide a better product at the end of the day. I think that's all about my study and the project. Thank you, everyone, and I'm open for any questions that you may have.